Hello everyone, this is Bishal Baisak and I am going to talk about controlled access and channelization. This comes under the topic multiple access. So we are also going to discuss the advantages of controlled access over random access. First, we are going to talk about controlled access or scheduling. By the name, you can see that there is controlled access to information provided to every station in a network. Let's get into that. It is a fair protocol. This means that it provides in-order access to shared medium so that every station has chance to transfer, as opposed to random access protocol where randomly chances are allocated to other station, which increases the chances of collision and traffic. But controlled access method eliminates collision completely. There are three methods for controlled access. As you can see, reservation method, polling method and token passing method. By the names only we can get a glimpse of the concepts, such as reservation method might mean that reservation is made by stations when they want to transmit a data frame. Polling method might be a chance or a permission that is taken by the first station when it wants to communicate with the second station. And token passing sounds like the method where a chance is given to every station turn by turn whether they want to send a data frame or not. So let's get into reservation method, the first one. This is the method where stations take turns in transmitting a single frame at full rate. Transmissions are organized into variable length cycles. Now this means that stations take turns in transmitting a single frame at full rate, which means the speed is not compromised and the single frame is transmitted without any traffic or collision. Each cycle begins with a reservation interval that consists of mini slots. Now what do you mean by that? That means every station can make reservations in a mini slots when they want to send a data frame, and by listening to the reservation of one station, every other station knows the order of reservation and they act accordingly so that no collision or traffic occurs. This is the diagram that can be used to describe reservation access method. The stations that made reservations can send their data frames after the reservation frame, which means that the order of reservation is followed. Suppose station 1 has made a reservation first and then station 4 makes a reservation, then station 1 will send the data frame first and then station 4 will be given a chance. Now you can see that 5 stations have made reservations, but no station is ready to send a data frame, which is why the value of 00000 is given to them individually. Suppose station 1 wants to send a data frame, then a value of 1 is assigned to station 1 whereas 0 is assigned to 2, 3, 4 and 5. Now if station 1, 3 and 4 all of them want to send a data frame, then the value of 1 is given to 1, to 3, to 4, and station 2 and 5 have no data frames to send, so they are given the values of 0 and 0. Now we are going to talk about the next method, that is polling. This is the method where stations take turns accessing the medium. How is this different from reservation access method? Reservation access method was where the stations have to reserve a time slot for their communication. But in polling, if suppose a station wants to communicate with some other station, then the station sends a poll, and if the other station is ready to communicate, then it sends an acknowledgement that yes, I am ready to communicate, and then the first station sends the data and the second station sends an acknowledgement that yes, I have received your data. There are two models of polling. One is centralized polling and the other is distributed polling. Now, what is centralized polling? As you can see, centralized polling has a primary station and other secondary stations. In a diagram, it is convenient to show only two stations. That is why I am using this example. So, if a primary station wants to communicate with one of the stations, then it sends a poll to the station. In this example, the primary station is sending a poll to B. So the primary station sends a poll to B. B is ready to communicate, so it sends an acknowledgement, and then the primary station sends the data to B and the B sends an acknowledgement. There might occur a situation where a primary station wants to send a poll to either of the secondary networks. Then it sends a poll, and if a secondary network accepts it, then it sends an acknowledgement, and then the primary network sends the data and the secondary network sends the acknowledgement that yes, I have got your data. Then we are going to talk about distributed model. In the distributed model, there is no such thing as primary station or secondary station. Every station can communicate with any other station it wants. The procedure is the same. It sends a poll, and then it receives an acknowledgement, and then it sends the data. Next, we are going to talk about the two states in token passing: listen state and transmit state. First of all, we need to understand that what is token passing. Token passing implements distributed polling system. What do you mean by that? Suppose there are four systems given: A, B, C and D. There is a token given to each system turn by turn, which is decided by some algorithm, if they want to send a data frame. So what is listen state? Listen state is where the destination station listens to the arriving bits and checks the destination of the sender if it matches to its address. If it matches, the frame is copied to the next station, otherwise it is passed through the output port to the next station. And what is transmit state? The station captures a special frame called free token and transmits its frames. Sending station is responsible for reinserting the free token into the ring medium and for removing the transmitted frame from the medium, which means that the sender is responsible for its token that has been inserted into the ring medium, and it has to remove the transmitted frame from the medium. So this is token passing. And one more thing, there is 1 bit delay whenever the listener listens to the arriving bit. The next, we are going to talk about the procedure of token passing in a flowchart. The station waits for the token, then it captures the token, and if it has some data frame to send, it sends the frame, and if the allocated time has expired, then it releases the token and the token goes to some other station. If there is no data frame to send, then it releases the token and no data frame is sent. Suppose it has a data frame to send, it sends the frame, and if the allocated time has not expired, then the station can capture one more token and send one more data frame. So that's it for the token passing network. The next multiple access technique that we are going to talk about is channelization. Channelization is quite different when we compare it to all the other protocols that we discussed above. Channelization is where the available bandwidth of a link is shared in time, frequency or through code between different stations. By the name channelization, it suggests that the channel through which communication occurs is distributed among stations so that they can communicate with any other station without any traffic or collision. Now let us go into the three protocols for channelization. FDMA, Frequency Division Multiple Access. By the name, it means that the frequency is distributed among the stations for communication. Then TDMA. Again, by the name, it suggests that the time frame is distributed among various stations for multiple access. And then CDMA, Code Division Multiple Access. We are going to discuss all the three in detail. First, let us get into frequency division multiple access. In this, the transmission medium is divided into m separate frequency bands. Each station transmits continuously on the assigned band at an average rate of R by M, which means that every station transmits continuously as many frames as it can on the assigned band, but the rate of transmission is R by M. In other words, the frequency is divided among the stations for transmission. The only disadvantage is that a node is limited to an average rate equal to R by M, where M is the number of nodes, even when it is the only node with frame to be sent. Even when the traffic is clear and there is no chance of collision to occur, it cannot increase the speed of communication. This is the diagram that can be used to describe frequency division multiple access. Suppose data station 1 wants to send data frame. Then the first slot is allocated to data station 1 in frequency table, in the frequency column. Data station 2 is given the second column, data station 3 is given the third column, and data station 4 is given the fourth column in frequency column. You can see there is a common channel, and in the same frequency there is slots allocated to every data station. The next method we are going to talk about is time division multiple access. By the diagram you can see that time slots are allocated to every data station. Data station 1 has the first bar, data station 2 has the second bar, data station 3 has the third bar, and 4 has the fourth bar. And again it is a common channel, and this time only time is allocated to every station. The entire bandwidth capacity is a single channel with its capacity shared in time between m stations, which means that this time there are not m nodes, there are m stations which are shared in time. A node must always wait for its turn until its slot time arrives, even when it is the only node with frames to send. This might be the only disadvantage in this method, that even when a node any other node has no data frame to send, still the node which wants to send a data frame has to wait for its turn until its slot time arrives, even when it is the only node with frames to send. This might waste time and might force the system to sit idle. A node is limited to an average rate equal to R by M, where M is the number of nodes, even when it is the only node with frame to be sent. Again, this might imply this, but a node cannot increase the rate of data transfer even when any other node is not ready to send a frame. Even when there is no traffic or collision, a node cannot increase or decrease its rate. So then the next method I am going to talk about is CDMA, code division multiple access. In CDMA, one channel carries all transmissions simultaneously. There is no turn or there is no channel individually given to any station. Each station codes its data signal by a specific codes before transmission. The station's receivers use these codes to recover the data for the desired station, which means that data of all the stations is taken together in a common channel. It's like a code, and then the station which has to receive the signal from another station has to decode its code from the common code and then receive the information. This can reduce memory, reduce traffic, and reduce collision. So these were some of the methods of multiple access in specific. Now let's go through all the methods one by one to revisit. Controlled access scheduling or scheduling. Controlled access is different from random access because it is much more efficient and provides collision completely. There are three methods for controlled access: reservation, polling, and token passing. Reservation is where station takes turns in transmitting a single frame at full rate. There are time slots or mini slots. When a station needs to send a data frame, it makes a reservation in a mini slot, and all other station knows the reservation order of the stations, so they act accordingly. This is the diagram. This will never result in collision or traffic. The next method was polling. It is where the stations take turns accessing the medium, but it is different from reservation access method. This is where there is no reservation of time slots, but a station sends a poll to another station if it wants to communicate, and the second station sends an acknowledgement that yes, I want to communicate, and then this data is sent by the first station to the second station. This was how polling has two models, centralized and distributed. Then comes the token passing network. This implements distributed polling system, which means that a token is given to every station in a network, and if the station has some data frame to send, then it uses the token as an opportunity to send a data frame. In listening, which means that if a destination is listening to the arriving bits from a sender, then the bits that it gets has 1 bit delay. It has two modes: listen state and transmit state. This is the algorithm of token passing. You have to wait for the token, which means the station has to wait for the token, capture the token. If it has data frames to send, it sends the frame and it checks if there is some time slot left or not. If there is no time slot left, then it releases the token and the process stops. The token goes to some other station, and if the allocated time has not expired, then it can see if the station has other data frames to send or not, and the same process follows again. And then the last was channelization. The available bandwidth of a link is shared in time, frequency, or through code between different stations, which means that the channel through which the communication occurs is divided between the stations as compared to random access or controlled access. There are three protocols for channelization, that was frequency division multiple access, time division multiple access, and code division multiple access. I hope this was easier to understand than controlled access. Frequency division multiple access, you can see that in the frequency side of the graph, every station is given a channel, is given a part of the channel. This will reduce collision or eliminate collision, and there will no traffic occur. See, this is a common channel and 4 different mini channels are given to station 1, 2, 3 and 4. In case of time, it's the same as frequency division multiple access, just that the part of time are given to 4 different stations. In case of code division multiple access, it is quite different from frequency division and time division, as in code all the messages or all the data frames are sent in a common channel using only one data. If any other station has to receive some data from the first station, then it has to decode its data from the common code in the common channel. This is quite advantageous, as I have said earlier, in terms of memory management and in terms of time management. And yeah, that's it. So I would like to thank my faculty, Mr. Ganeshan sir, who has given me this opportunity to explain this concept and express my knowledge in that concept. Thank you very much.